In this lab, we're going to put the code together so that you can actually start playing Battleship. And you'll be playing Battleship against the computer, and our first go at the computer AI will be a simple random guesser. So let's get started. In the README, you see a list of all the places we'll need to add code. There's a fair number of spots here, but we'll find that a lot of them are just a few lines of code each. But let's go ahead and do this in order. The first file we're going to look at is human.py, and that's going to be the code that allows us to get a guess from a human user, right? Someone sitting at the keyboard. Here's the get guess. The idea here is we're going to use a utility function called getKeyInput, which is going to perform the necessary kind of Pygame code to actually read the keyboard, and it's just going to give us a single key back. And we'll have to do the checks ourselves to make sure the two keys that have been pressed represent a valid Battleship guess. So let's give ourselves two variables, one for the row and one for the column. And initially these will be invalid. So just to check that we end up setting both of these correctly, it's nice to initialize them to like known bad values. Now if we see -1 somewhere else in our code, we'll know where it came from. Oh, it must have come from the get guess, and we didn't go through our logic correctly and actually reset these to something valid. All right, so to get the key, we'll get the row first. And so key equals utilities dot get key input. And at this point, key will be some single character, like an A or a 7 or an asterisk. Now I want to make sure that the key represents a valid letter A through J. So here's the trick. If key is not in the lowercase letters, not all lowercase letters are valid though, only the first 10 lowercase letters are valid. So if it's not in that list, then I'm going to use this alert function to show the message bad row. Now alert is passed into getGuess as a callable function here, and we'll let the game engine and the rest of the code figure out what to do with this. It turns out this will actually be calling our display message back in main.py to show this to the user. But now I need to get another guess. And in fact, I'll have to keep getting guesses until I don't actually hit this if statement. So let's go ahead and go back up to here, line 35, and wrap this whole thing in a loop. And I don't know how long I'm going to have to do this for. I'm going to have to do this forever until I don't get a bad row. If it is a bad row, I'll use the continue keyword to stop execution of the loop and to go back up to line 37 and get a new row input. All right, so this will be reading the row. Now, if it is a valid guess, I need to convert the letter into a number. Now, there's a lot of ways to do this, but here's one technique. I can use that same lowercase list, but now I'll find the key, and that will give me the index of the match. And since I know it's already in here, I know that's going to be a valid value, and it will be 0 through 9. Now let's do a similar set of code for the column. Read the column, and I'll get another key. And in this case, I want to make sure that's a digit. And any digit is valid, right? 0 through 9. So if it's not in the digits, then I've got a bad column. And I need to stop execution and ask for a new guess. Note that we're not going to ask for a new column, we're going to ask for a whole new guess. Another row and another column. And I'll do the same trick to convert column into a number. Remember that this is the letter 8 or the letter 7, and I want the number 8 or the number 7. So I need to convert it using the same find technique. And at this point, I know that I've got a valid row and a valid column, and I'm going to simply return these. And by returning them, I'll break this loop. So now I can remove line 50. All right. And that will be enough for the get guess for the human. Now, for the computer, we're going to get the guess in a different manner. So let's go to computer.py next and make sure we get this code squared away. So the computer is going to get a random guess, but we should make the computer, not guess the same spot twice. So in the init, when we first build a computer, let's go ahead and create a list of all the valid battleship spaces. So that's going to be a set of 100 tuples, right? Row, column, pairs. For row in range 10, for column in range 10. Now unguessed spaces is initialized to an empty list at line 16, so I'm just going to append this guess. And note that these are numeric values, 0 through 9 in both cases. It's only a human that deals with characters, right, A through J. We saw in human.py we went to some links to make sure that the row column we returned back were numeric. For a computer, it's actually much simpler. We're always going to be using numbers here. Now, this is all of the unguessed spaces. When we get a guess, we can just pull a random value out of here. So I want to find a random value. And there's, again, many ways to do this, but here's one technique. Let's find the spot, a random index in this array. So it can be any integer between 0 and the length of the unguessed spaces minus 1. So if it's an array with 3 elements, 0, 1, or 2 would all be valid indexes. And then the guess is going to be the value at that location. Now, if we were to just return guess at this point, we'd find the computer be quite bad at Battleship. It's already going to be bad enough. We don't need to make it any worse by guessing the same spot multiple times. So let's go ahead and remove this guess from the array, and this will make the unguessed spaces get shorter and shorter. And we know there's only one match here. Each element in this unguessed spaces is unique. There are 100 of them and each one's different. And so we're going to remove all values that match this, and that's going to just be 1. And so now our array will be 1 shorter than it was already. So the time.sleep is just to make the computer appear to be grinding through its options. This would actually execute pretty much instantaneously as far as the user is concerned, and could cause the game to look a bit quirky. When you type a guess, you'd actually see 2 simultaneous things happen, your guess and the computer's guess. This will make it look more like one person's playing and then another's playing. So you can play with this sleep value, and when you're testing, maybe you'll find it convenient to remove this, but I think during play you'll find that this actually makes the game much more intuitive. Now, of course, we're not going to return 0, 0. We're going to return the guess. Okay, so now we've got the ability for both humans and computers to make guesses. Let's put them together in the engine.py file, which is going to actually run Battleship. It will ask player 1 for a guess, check whether that guess is a hit for the other player, and then vice versa. So here is the play function in engine. It's going to do this forever, and the way you'll break out of this while true loop is find out if somebody's all sunk, right? If player 2 is all sunk, then player 1 won, and vice versa. So I provided you all of the code to implement player 1's turn. You just need to follow this same logic, flipping the roles of player 1 and 2, because Battleship is a symmetric game. So we can actually just Control-C this and very carefully paste it here, and then we'll go through it and make sure we understand what's happening, and also that each one of the players is their roles reversed. So now this is player 2's turn. And so we'll ask player 2 for their guess, self.player2.getGuess. And we'll need to tell player 1 about that guess. And then we're going to get the result, whether that was a hit or a miss, by asking player 1, what's your state? That will give us player 1's state. And will let player 2 know about this? Now at this point, if you source through the code, you'll find that neither humans nor computers really do much with this send state. But for the next lab, when we start working with multiplayer on 2 different computers, we'll find this is quite an important step. So we're going to tell player 2 about player 1's state. And if player 1 declares a hit, then we'll have to keep track of that information. Otherwise, it's a miss. And now we'll want to draw all of the pieces on board 1. And on board 1, we'll have player 1's hits and misses. And at this point, player 1 might have lost. If they've lost, player 1's lost, and the winner, of course, is player 2. So you see, we're just going through all of the code that was already provided for player 1's turn and flipping it around. And this symmetry actually implements both sides of the battleship game. All right, so that's all that we need to do for the logic. Now we need to go and actually implement some graphics here, which are handled separately from these logic classes. So the utilities file is going to be in charge of actually drawing the hit and miss sprites to the board. Let's see what these look like. So just like draw ships here was given a board and a bunch of ships, and we went through very carefully and pieced together the ships out of individual sprites, we'll do the same thing here. We're given a board, and now rather than a list of ships, we're going to have a list of hits. So what should I do? Well, I should go through this list one by one for hit and hits, and simply put the appropriate sprite on the board. Now for the ship, it was tricky because there were multiple sprites for each ship, but for one of a hit or a miss, it's very simple. It's a single sprite. So board.add sprite, and the sprite that I want to use is, in this case, the hit sprite. And the location that I want to put it, well, it's at the hit location. Remember, hits is a list, and what's inside the list? Each item in the list is a tuple, a row, comma, column. So this type annotation here, this type hint, tells us what to expect in the hits parameter. And that's it. Draw misses, very similar. For miss in misses. So we're going to go through the parameters we're given. This is a list. We're going to go through each item in it, calling it miss each time. Okay, and what are we going to do with that information? We're going to add a sprite to the board. We're given the board, right? That's this other parameter. Sprites.miss. And in this case, a location. Now, maybe we could also say for location, right? But I think it's more idiomatic to use the singular version of the plural name here. But these are, again, locations, row, comma, column tuples. All right, so we've done our 2 utilities here for draw misses. And now we're going to switch gears here. We've talked about how do you get a guess from each player. Well, now on the other side, how do I tell whether a guess was a hit? Well, if we trace through, we see there's a send guess. A player receives a guess. And if we go to, for example, a human, that send guess is actually itself a call to a function. It's going to its player state and saying add the guess. Right, so now we'll go into the player state. And what does that look like? So we've already talked about place ships. Add guess. So now it's going to go through each of its ships and check, is the ship hit? If it is, append that as a hit and set this hit flag to be true, meaning the most recent guess was it was a hit. But how do we know if a ship is hit? Well, let's go to the ship file. And so you see its objects all the way down. Well, is hit, all of a sudden we're responsible for this. So finally, after several layers of indirection, now somebody actually just do the hard work of figuring out whether a particular row and column has hit a ship. And to do this, we'll need to do some array logic because we know the bow location of the ship and we know that it's horizontal or vertical and we know its length, so we can figure out whether a particular row or column is on this ship. So we'll need to do a loop, and there are length locations in the ship. So for I in range self.length, and now if the ship is vertical, and the guess, that particular location, is equal to the row plus the offset, how far we are along in the loop, and the single column that this whole ship is on, well, then we've got ourselves a hit. Self.hits.append, so the ship will now have an additional hit, and it will let whoever called it, in this case player state, know that that guess is a hit, and we won't need to go through any other checks for other ships in this case, right? Because ships can't be on top of each other. Now, if the ship is horizontal, all of its tiles will be on the same row, but each tile will be on a separate column. So we'll have a separate check here. If not, self.is vertical. In this case, we want to check to see if the guess matches the fixed row and the changing column. In which case, again, we have a hit. Now, these conditional statements here are a bit tricky. It's very important that you don't put an else here, because I want to check for the case that it's vertical and simultaneously whether it was a hit. If you put an else at line 47, that would be the case if it's horizontal, fine. Also, if it's vertical and it was a miss otherwise, in which case you'd erroneously put a hit here. So look at these carefully and make sure you understand what's going on with each if being independently evaluated. Also notice that I'm using the loop counter I, loop index I here, to change the row index for the case of vertical ships and the column of horizontal ships, while keeping the other side constant. So it's a tricky bit of logic here, which is why you're implementing it. But the end result is that a ship can tell you if a particular row and column is on it, right, is a hit. And finally, we want to check player state should be able to tell you if you've lost, right, if all the ships are hit. So let's go to player state now and finish this up. So here we've got all sunk, and the idea here is that we're going to return true only if all of my ships are sunk. Otherwise, return false. So let's go through each of our ships for ship and self.ships. And now the logic we could go either way here, but we'll find it's a lot simpler if we use a not ship.isSunk for our if statement. If the ship is sunk, it's ambiguous. We don't quite know what to do. Maybe we keep playing, maybe we've lost. But if we know that a ship is not sunk, and that's the only thing we know, that's enough to actually return out of this function because we haven't lost yet. If we find a single ship that isn't sunk, we haven't lost. We're still in the game. In this case, we can return false. Now, if I go through this loop and I never hit line 107 because each ship is in fact sunk, I'll still be in this function, and therefore at the end of here, I'll return true, meaning that, oh well, I actually have lost. Okay? All right, so let's go ahead and try out our code here. We can click run. And now we see our ships, and we don't see the computer ship, so we can begin guessing. Maybe D3, G6. You got to be out there somewhere. Ah, we got something, right? So now we can follow that up, and there we go. You see the ship appears once it's been sunk, and we're going to handily beat the computer here. Notice that the computer doesn't actually follow up on a successful hit, and that's a result of the AI we've written. It's just random guesses. So as you develop your code, let me show you some tips to improve the debugging experience, right? We could just sit here and play Battleship a lot, but this will get tedious quickly. The first thing I recommend is reducing the amount of ships out there on the playing field. So if we go to player state, you can see ship types. This actually defines all of the ships used in Battleship. And we've used 2, 3, 3, 4, 5 here because that's the pattern of ships used in the toy game, destroyer, submarine, cruiser, battleship, and an aircraft carrier. But we can simply put a little destroyer out there. And this will make it easier to win and lose. We only have to guess twice. Another thing we can do is actually show the computer's location. So if we go into computer.py and change this debug flag to true, then we'll find that we get a text representation of the computer's playing field. In this case, its single destroyer is sitting at A, B, C, D, 0, 1, 2, 3. So D3 will be a hit. We can guess D3. Sure enough, that's a hit. A miss would be like, for example, G1. Now, if we wanted to win the game, we could say D4, and then you win. When we click X here, we'll see buy. So that's a technique you can use to improve the debugging experience. Put that back to false, and then return player state to its original value. And we'll be back to the normal Battleship. Now, if you'd like to play a interesting variant, we could try other patterns up here. Maybe a 6 and a 10 for 2 big ships, right? Now you can play Mega Carrier. So we have total control over the code here, as you do when you write your own game, and be creative. All right, so that's it for this lab. And next up, we'll be playing Battleship with another human over a serial connection.